Now it's time to look into the deciles. Deciles are similar to quartiles, but they divide a data set into 10 equal parts. Let me show that. So this is the overall data set. Let's take, we have 100 data points or 100 records or 100 observations. Now the overall 100 data points will be divided into 10 equal parts: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So total 10 equal parts. The data has been divided into 10 equal parts. That's what the deciles do. Deciles will, the deciles divide a data set into 10 equal parts, representing the first D1. This is decile 1. This is decile 2. So what it do? Decile 1 is nothing but the 10th percentile. Decile 2 is 20th percentile. And decile 3, 30th percentile. Let's see. So decile 1. What decile 1 consists of is, decile 1 holds the 10 percentage of data points of the total data. So that's why it's 10th percentile. And then decile 2 holds total 20 percentage of data points from out of total number of data points. That's decile 2, D2. Similarly, decile 3, 30 percentage of data. Decile 4, 40 percentage of the data. Decile 5, 50 percentage of the data. If you put it in another way, so it's nothing but decile 5 is nothing but decile 5 represents 50th percentile. That represents the value, a value below which 50 percentage of the data falls. See, 1, 2, 3, 4, 5, 50 percentage of the data falls below this decile 5 value. Same goes with the decile 6, decile 7, decile 8, and decile 9, and goes on to the decile and goes on. And finally, total 100 percentage of data set will be fit here. Okay. So now let's take one example for the deciles, and then we will move on to the next. Then we'll move on to the next tool. Okay. So each part. So decile, they divide a data set into 10 equal parts that you see on screen, representing 10th, 20th, 30th, 40th, 50th, and so on percentiles. So deciles provide additional granularity in understanding the distribution of data in a data set. Now it's time to get into the example. So deciles, as usual, data is the one we are going to take. Let's convert, I think, let me check the data frame for this, DFD, that's data frame deciles. So PD dot data frame, and inside that the first one is data, and later let me put the data, and DFT, this is our data frame. This is ready. On top of that, this we are going to convert that into the deciles. Let me say deciles is equals to DFD data, and as usual I'm going to use a quantile only, nothing new. And inside that I want deciles, so that's why I will mention the percentages first. 10 percentage or 10th percentile is decile 1. What decile 1 is nothing but it represents a value below which 10 percentage of data points falls. Okay, similarly 0.2 decile 2, 20% of data falls. 0.3, 30% of data falls below that value. Then 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and that's it. Okay, so now let me print the deciles. Let me print deciles 10th percentile. 10th percentile is nothing but decile D1. So deciles dot log 0.1. Sorry. Deciles. Sorry, that's my mistake. Deciles 0.1 as it's 6.4. Similarly, let's find out other deciles also. So decile 2, 0.2, decile 3, 0.3, decile 4, 0.4, decile 5, 0.5. It's your mean, it's your quartile 2, sorry, decile 6.6, decile 7.7, decile 8.8, decile 9.9. Yep. And let me execute it. And here are your deciles. So 6.4, 8.4, 11.2, 14.8, 17.5, 19. So if you can just map them all together. So decile 1, decile 2, decile 3, decile 4. So just to put it here. So 10% of data points are 10% of data points are falling below 6.4. 20% of data points are falling below 8.4. 30% of data points are falling below 11.29. 40% of data points are falling below 14.8. 50% of data points are falling 17.5. That's quartile 2. And 60% of data points are falling below 19.2. And 70% of data points are falling below 20.9, and 80% of data points are falling 24.2, and 90% of data points are falling below 27.3. And this is deciles for you.